Hey guys, so today, as we move forward, we're going to start with the elimination method. And part of me really thinks you'll like it more, only because this math nerd likes it a lot more too. Okay, so what I need you to do is I need you to have your workbook handy on page 231, and I need you to have some Scrappy-Doo, notebook, paper, whatever handy as well. Okay, so pause the video now, grab those two things, workbook, page 231, and some scrap paper. Okay, now that you have your things, you're going to go ahead and set up your scrap paper with the title Elimination Method, and then writing down the two systems, x plus y equals 21, x minus y equals 9. So when we begin with the elimination method, we're going to notice that our equations do not have one variable alone. So with the substitution method, we are looking for which variable is isolated on that side of the equation. Here, we're looking for, they're x and y are on one side of the equation, and they're kind of balanced out. There's x's on top of x's, y's on top of y's, and numbers on the other side. The next thing we look for is if there's total opposites, okay? And we're looking for opposites because of that word elimination. We want to eliminate a term. We want, just like before, we needed to get all of one type of variable. Well, now we still have x's and y's we can't solve. So we need the x's to go away, or we need the y's to go away. We need to eliminate them. So as I notice here, I have x and x. I have a positive y and a negative y. And then I have 21 and 9, which doesn't have anything to do with eliminating the variables. These are complete opposites. This is positive 1, and this is negative 1. These are both positive 1, so they are not opposite. So it looks like we are going to be eliminating the y's. So what we do is we put in a big fat bar, and we add these up. And what happens when we add the equations, we have 1x plus 1x is 2x. 1y minus 1y eliminate. The equal sign is brought down, and 21 plus 9 is 30. So we kind of like do traditional addition and get an equation. So we'll solve that out. We get x equals 15. And again, in order to solve the system, we need a solution that has the x value and the y value, or the value of both variables. So we've solved that x is 15. So now we can take one of those equations, plug back in. I'm just going to choose the first one. Plug in 15 for your x value. I don't know why you put a comma there. And solve for your y value. So let's move the 15 on both sides. We get y equals 6. So again, placing that up there in our solution and bubble clouding it. So our answer to the system is 15, 6. Okay, now, that being said, we're going to try another example before we move into our workbook, which has some harder examples, okay? All right, so on your Scrappy-Doo, let's go ahead and write down 3x minus y equals 12. Then 4x plus y equals negative 33. Again, we're looking for opposites. Sometimes the opposites will be the x's, sometimes they'll be the y's. It doesn't really matter. We just want to have those opposites so we can eliminate. Again, I'm seeing that the y's are the opposites. The x's are 3x and 4x are not opposites. So we'll put in our big fat bar and we'll add those together. So we get 7x's, these cancel, equals negative 21. And again, solving that out, divide both sides by 7. We get x is negative 3. Okay, let's set up our xy. So we can put our negative 3 into our solution set. And we have to solve for our y value. So I think I'm going to choose the second equation this time. Why not? So we have 4x plus y equals negative 33. We're going to substitute in that negative 3 for the x value. So 4 times negative 3 plus y equals negative 33. In order to solve for y, I have to simplify this multiplication here. So we have negative 12 plus y equals negative 33. And now I can move that negative 12 by adding 12 to both sides. Y equals negative 21. And that's it, because y was all alone. It had no coefficient. So we can go ahead and place that up there, negative 21. Okay. So So those are like our most basic examples where we have like already opposites set up for us, okay? What we're going to do now is we're going to turn to page 231 in our workbooks. And what we notice here is when we look at exercise number 1 and we look at the system that we're given, we notice that the x's are not perfect opposites and the y's are not perfect opposites. So we have to do something that is called using the multiplicative equality property. So we can change the equation, but if we decide to change it, that means we have to change it fairly, if you will. You got to make sure you're distributing that same thing to everything in the equation. So let me show you what I mean. Here it wants me to eliminate x to solve. So that means I need to make the x's opposites. So I have 4x and I have negative 2x. Well, it's good that one is positive and one is negative already because I don't have to factor that in. However, I know I can make 2 into a 4, right? By multiplying it by 2. So if I multiply that by 2, I must multiply everything by 2. So I'm going to multiply that whole entire equation by 2. And it's going to be the same equation. It's just going to look different, kind of like we talk about how we can make equations have different Halloween costumes, right? We're disguising it. So let's bring down this first equation, 4x plus 5y equals 12, because it's staying the same. And now let's distribute that 2. So 2 times negative 2x is negative 4x. 2 times y is positive 2y. And 2 times 8 gives me 16. So the new equation, the new disguised equation, is negative 4x plus 2y equals 16. I have made opposites of the x's. So now they will eliminate. So let's add these together. These eliminate. 5y plus 2y is 7y. And 12 plus 16 is 28. Divide both sides by your 7. And y equals 4. So again, we have half of our solution, making that xy. We know that y is 4, and we need to solve for the x value. So again, we can choose either equation. I think I'll choose the first one. We're going to plug in our 4 for our y value. So 4x plus 5 times 4 equals 12. Now we have 4x plus 20 equals 12. Now we're going to move our 20. We get 4x equals negative 8. Divide by 4. We should have x equals negative 2 and place that into your coordinate. So our answer is negative 2, 4. Now what we're trying to show you in exercise number 1 is that you can eliminate the x's by manipulating the equations that way, but you can also eliminate the y's. If you see something that might catch your eye before the other thing, you can eliminate something, different than your friend and still get the same answer. So let's check it out. If we want to eliminate the y's, we have a 5y and a positive 1y. How would we get rid of that? How would we make them opposites? Good. I would keep the 5y too, and I'd make this 1y a negative 5. So in order to do that, I need to multiply this whole equation by negative 5. So again, that first equation is staying the same. Doesn't always work like that. And we're going to distribute that negative 5 through. So we should have positive 10x minus 5y equals negative 40. Put your big fat bar in and go ahead and start solving. It's okay to pause the video and go ahead and then play again, okay? So when we add, we should get 14x equals negative 28. Dividing both sides by our coefficient of 14, we get x equals negative 2. So again, up here, I'm going to make my xy, and my x is negative 2. Now, we know the answer already for y should be 4, but we're going to keep going. So picking one of those equations, I'm going to stick to that first one, substituting in the value we just found. And y again should equal 4. So this is just to show you that we can do it either way. So there's no right way, there's no wrong way. You could actually have multiplied each equation. I don't know, let's say you wanted to make this one 16x and this one negative 16x. You could. Let's say you want to make this one 10y and this one negative 10y. You could. Okay? It's okay to as long as you're mathematically doing the balancing the equation, you're good to eliminate what you want. Okay? And again, notice I'm using multiples. I'm not just grabbing weird numbers. Like I can't just make this, I can't just make it 9x because it's not a multiple. Okay? All right, let's take a look down here. So I'd like you to pause the video and get started and try it out, and then play it when you need to. Pause, play, but try to do this one on your own. Okay? Here we go. Okay, so we're going to solve by elimination. I don't have opposites as my x's or my y's, so I just basically need to choose. And what I do could be totally different than what you did. I am going to play with the fact that these were already a positive and a negative. So I'm going to multiply this top one by 7, and I'm going to multiply this bottom one by 2. I'm hoping to get opposites for my y's. So I'll end up with 35x minus 14y equals 70. And 4x plus 14y equals 86. Again, if you did not do what I did, just watch me. Watch the flow, see if I'm doing it right, and see if you get the same answer as me. Okay? So we're going to add these together. We'll end up with 39x's, the y's cancel, equals 156. We're going to divide both sides by 39, and we should get that x equals 4. Okay? So in my XY solution set, I should have a 4 for my X value. So now I'm going to take one of the equations. I don't know. I'll use the second one. And I'm going to plug in the 4 for the X value. So 2 times 4 plus 7y equals 43. Simplifying that 2 times 4, I get 8 plus 7y equals 43. Subtracting the 8, we get 7y equals 35. Dividing by 7. Y equals 5 after all that. Looking at those equations and that system, I really would have thought my solutions would have been larger than they were. So 4 or 5 is the correct solution set for this system of equations. Okay, that is it, my friends. Your job tonight was to finish the video and be ready for tomorrow. So we're good to go, and I'll see you tomorrow for more practice. Bye.